Hello, welcome to today's lesson on section 10.3, which is about defining and using probability. So as most of you should know, or you don't, but we'll define it anyway, probability is defined as the number of favorable outcomes divided by total number of outcomes. So what that means is that the probability, which I'll abbreviate like that, will always be between 0 and 1. You can never have probability higher than 1 because you can never have more favorable outcomes than total outcomes. For example, if you had like 100 marbles and 20 of them were green, you're not going to have more green marbles than the total number of marbles in your jar or anything like that. And also, you can't have a negative probability. That wouldn't make sense either, because how can you have a negative number of marbles? So if you think about it, probability's got to be between 0 and 1. It can't equal 0 if it never happens. It can equal 1 if the situation always happens. Another thing I want to mention is theoretical and experimental probability. Theoretical probability is what you expect to happen. Experimental is what actually happens. It's basically when you try this on your own. So let's start with the first example. You want to find the probability of rolling a 5. So if we think about it, there's only one way you can roll a 5 when you're rolling a 6-sided die. Because remember, a 6-sided die kind of looks like this. Where you have a 5 on one of the faces and a 1 on the other face and so forth. So there's only one way you can roll a 5 out of 6 possibilities, so the probability is just 1/6 of rolling a 5 when you're rolling just one 6-sided die. Let's say if you want to find probably rolling a prime number. Now, if you think about it, a prime number has to have exactly 2 factors, in case you forgot. So for our numbers 1, 2, 3, 4, 5, and 6, which ones are prime? So take a second to think about it. If you said that 2 is prime, 3 is prime, 5 is prime, congratulations. You got it right. So what that means is that the probability will have to be 3 out of 6, or 1/2. So there's a 50% chance, or 1/2 chance, that we will get a prime number when rolling a 6-sided die, because 3 of the 6 outcomes were favorable, meaning that's what we wanted. We wanted a prime number, and 3 of them were prime. And of course, there's 6 possibilities. Let's look at number 2. Let's say you have 20 index cards labeled 1 through 20, placed face down. Find probability of selecting a card as a perfect square. Well, if you think about it, the numbers 1 through 20, those are perfect squares. And because there are 20 possibilities, the probability is 4/20, or 1/5. Same thing as saying 20%. Find probability of selecting a card that is a factor of 30. Well, the factors of 30 are the following: 1, 2, 3, 5, 6, 10, 15, and 30. But remember, our cards are only 1 through 20. So we don't care about using 30, but we do care about these 7 numbers. So the favorable situation, meaning that you pick a number as a factor of 30, there's 7 favorable situations, and there's 20 total situations. So the probability would be 7/20. So hopefully those kind of make sense. Just look at what you want, divide by what's total. So favorable, probably another way of looking at it is what you want. And total is what's possible. Okay, let's move on to example 3. All 5 freshmen in period B are presenting a problem to the class. Find probability that they present in alphabetical order of their last names. So this is a little tricky, but if you think about it, how many total outcomes are there? You really want to think about this one. You might want to pause the video and kind of think about it. If you said 5 factorial or 120, that is right, because the thing is that we can put these 5 freshmen in any order. Like say this is the first person, that's the second person, the third freshman, the fourth freshman, the fifth freshman. There's 5 ways I can select the freshman for the first one to present to the board. Then after that's 4, 3, 2, 1. So it's almost like using the multiplication counting principle. Or you can use a factorial because you're looking at how many ways to arrange n items or n people. Now, how many will be favorable? Well, obviously there's only one way I can get an alphabetical order. So the answer should be 1 over 120. Let's look at example 4. Okay, also in period B, I have 5 freshmen, 6 sophomores. 2 students are to be selected to bring the laptop cart to our classroom. Find the probability that both students selected are freshmen. So what is all the total outcomes? Of course, I have 11 people to choose from. And so I want to figure out how many ways I can select 2 out of 11 people. So this would be the number of ways of selecting 2 out of 11 people, regardless of class, whether they're freshman or sophomore. Favorable outcomes, because we only want freshmen, so obviously that's going to be 5C2. The reason I say 5C2 because you're looking at the number of ways of selecting 2 freshmen out of 5 students, or out of 5 freshmen. So we want to do 5C2 over 11C2. Using your calculator, you get 10 over 55, which reduces to 2/11. So that's a little tricky, and we'll have to kind of review that when we meet as a class. Here's a cool one, Mega Millions Lottery. So for those who are not familiar with how the lottery works, you got to select 5 numbers from 1 through 56, 1 number from 1 through 46. Order does not matter. And that was the case in the last problem as well. We didn't care about the order in which I selected the freshmen to go get the laptop cart, so order didn't matter. So if you think about the total number of ways I can select 5 numbers from 1 through 56 and 1 number from 1 through 46. So 56C5 is all the ways I can select 5 numbers from 1 through 56, and 1 number 1 through 46 is 46C1. So again, all the ways I can pick 5 numbers out of 56, 56C5, all the ways I can pick 1 number from 1 through 46, 46C1. And then we want to multiply since we're using the multiplication counting principle, because we're counting all the ways I can select 5 numbers from 1 through 56 and 1 number from 1 through 46. There's only one winning way, obviously. So the probability will be 1 out of 56C5 times 46C1. If you work all that out and using the calculator, that's why they say I have a greater chance of being struck by lightning, because there's really a very unlikely chance that you're going to win the lottery. It's 1 out of 175,711,536. So tonight the lottery is worth $170 million. So you could buy 175 million tickets, get all the combinations, but you still would lose $5 million. So it's almost like you need the lottery to go up to, over 175 million, like say 200 million, to make it worthwhile to spend a dollar on every possible combination. So that's how that works. And if for some reason I'm not at school tomorrow, that's probably because I won the lottery tonight. So good luck with the new Algebra 2 honors teacher if that happens. But as you can tell, it's very unlikely, so most likely I will be at school tomorrow. Number 7, I'm going to leave for you guys to do on your own. And I'll make a Google Docs form and ask you for the answer to that question. But this one deals with poker. But just so you know, there are 4 cards of each type. So obviously there's 4 8s, there are 4 kings, 4 queens, 4 10s, and so forth. So keep that in mind. And also keep in mind there's 52 possible cards. Before drawing any. So keep those in mind and see if you can get the answer to this question. And I actually wound up losing to this guy. So this guy did get, I think he wound up getting an 8. That's right, he got an 8 on the last card that was drawn. So find the probability of that happening. And you can see why I was very unhappy that that happened. Lastly, we want to look at geometric probability. So let's say we have a dartboard that looks like this. Let's say the large radius is 10 inches, and using a new color, let's say the small radius is 1 inch. So assuming that Kamo will hit the board, he's not a bad dart player, he'll actually hit the board, what's probably he'll hit the bullseye to beat me? So if you said 1/10, you're wrong. It's not 1/10. Remember, we want to find the area. So the area of the bullseye divided by the area of the board. And if you think about area of a circle is pi r squared. So it'll be pi 1 squared, because the radius of the bullseye is 1 inch, over pi 10 squared, because the radius of the whole board was 10 inches. The pi's will cancel, so you get 1 out of 100. So if Kamo were playing, this is hypothetical. Actually, I think I would beat him pretty badly in darts. So, but just so you know, that's why bullseye is really tough to get, because there's usually about 1 out of 100 chance you'll hit that. Lastly, number 9. Let's say you have a weird kind of dartboard like this here, and you have a square inside of a circle and a circle inside the square, and you shade the part that's between the square and the inner circle. What's the area you'll land in the shaded region, assuming that you'll land somewhere in the figure. So there are no dimensions. So is it impossible? Well, I never present you with impossible problems. We could always do these. No, it's not impossible. Here's what you do. You can make up numbers. Let's say I put the side of the square as being 2. So obviously all sides are 2. So the area of square is easy. That'll be 4. The area of the inner circle, because if you think about it, since the side of square is 1, half that will represent the radius, because the side of square so happens to be the diameter for the inner circle. That'll be pi. So the area of the shaded region is the difference between this square and the inner circle, which will just be 4 minus pi. And remember, probability is favorable divided by total. So in this case, area shaded minus area of the outer circle. So we're almost set here. We have 4 minus pi up top. Now, using a little bit of geometry, if we think about it, if that's 2 and 2, that has to be 2 root 2 if you use the 45, 45, 90 ratios or Pythagorean theorem. So you can use Pythagorean theorem or 45, 45, 90 ratio, which is just 1 to 1 to root 2. So it means the radius of the outer circle will have to be root 2. So that makes the area of the outer circle 2 pi. And so that would be my probability, which is roughly equal to 0.137. Someone might ask, what if I chose different numbers? Would it matter? Would different numbers matter? No. Why? Why? Because probability is a ratio. And so if you make one thing bigger, the other stuff will also get bigger too, so it all will work itself out. So that's why it wouldn't matter what number you chose. So that concludes the video on probability. We'll have a discussion on this when I see you guys in Block 2 this week. And that's it. So have a great rest of the day, and I'll see you guys later this week.